Guys and girls, it's know it time!
Alright guys and gals, I'm going to just go over some quick graphing ideas with you. I want you to plot this. Y equals to negative 4 sine, open bracket, 2 theta minus pi plus 4. Draw a quick sketch and label the axis for me, please. I'm going to pause it and let you have a... So if I were to draw a quick sketch, again, to save time, I'm going to start this right now. Nothing too bad. First of all, I know this is a negative sine graph. Okay, so we know it has to start in the middle, and it goes down. But here is my starting point, right here. Abraham, what is that point going to be? This point right here. No, not pi. Pi by 2. You got to factor out this 2. Remember, that's the key, because a lot of students are going to get slaughtered if you don't do that. Pi by 2. So now we know my graph goes something like this. Again, I just draw a very, very, very rough sketch. Okay. Label your endpoint. Practice. Okay, so this is going to be 4. This is going to be 8. And this is going to be 0. Very simple. Nothing too bad. So now, you got to tell me what these points are. This is the key. This is not pi. There's a formula to get endpoint. You got to know all your formulas like the back of your hand. Yep. It's your first point plus period. So in this case, it's pi. So I know my period is pi. To get your endpoint, remember we take my first point, which is pi by 2. There should be a 2 here. Where did it disappear? Plus pi. That gives you 3 pi by 2. But we're not done yet. I want you to find the middle, and the middle, and the middle again. Guys, gals, get crack-a-lackin'. You're going to hunt down all those 3 points for me. Again, all this is based on is, do you know your formulas? Midpoint. Pi by 2 plus 3 pi by 2, that's 4 pi by 2, that's 2 pi. Divided by 2, and you get your answer here, which is pi. Then do the midpoint again. These key points right here. It's just basic over and over again, no tricks to it. So if you did that correct, I believe this is 3 pi by 4. Nope, you got to divide by 2. Okay. And you do the exact same thing with this one. Pi, 5 pi by 4. No tricks. That was pretty simple, and that's all you have to do. Now, I'm going to give you this graph. I'm going to show you how to work with this. Your graph is y equals to negative 4 cosecant 2 theta minus pi plus 4. The question now is, I have a new shape. This new shape is cosecant. You can, but in a second I'm going to write a few things down. This is where students have trouble with star. To answer secant / cosecant questions, you must, this is a must now, draw the graph. A lot of students, they try to answer this without drawing the graph. Guys, gals, to answer it, you have to draw the graph. Let's use another color. That color doesn't work too well. You must draw the graph. No exceptions to this rule. Okay. So the key is, how do you draw a cosecant? To draw a cosecant, here's my steps to success. Steps to success. Double C, double S, and you'll always succeed. 1. Rewrite the question using sine / cos. What I'm going to do is I'm going to rewrite the question using sine and cos. 2. Draw your sine / cos graph. Okay. The first 2 steps is easy. We just did the first 2 steps without realizing it. 3. 3 is a bit of a new one. Find your asymptote. I'm going to write a little message for you on asymptote. Little star here. This is where your graph crosses the center line. So this is where your graph crosses the center line.
So pretty much
That's all it is. And finally, step 4. Go with the flow. Go with the flow. I'm going to show you step by step how to do this. So guys, I'm going to write down my equation. Y equals to -4 cosecant. Cosecant 2 theta minus pi plus 4. Step 1, you're going to rewrite this using either sine or cos, and you got to make sure you have the right one. This is why you got to know. How do you know sine?
the opposite.
Because this is C. Remember the little trick I taught you? Guarantee you when you're in university, 10 years from now, you will never forget it ever again. And up to this day, that's the only way I remembered it. Okay? I was playing around in grade 12. I'm like, hey, there's a trick to this. And I remember up to now.
So they didn't tell you the trick?
I just made it up.
You should publish that.
I should publish it, eh? So when I was in grade 12, 3 years ago, this is what I learned. Okay? 3 years ago, guys. I was sitting there. 3 years ago, I was sitting where you are and looking up here.
3 years ago, you were my grade 8 math teacher.
I was in grade 12 then. I was in grade 12 then, Grumpy.
Not even 3, 4 years ago.
Why?
Yeah.
I can see you're good at math, Grumpy. Why? So first thing, I'm going to rewrite this using sine. -4. Now technically you should rewrite this as 1 over sine. But I'm just going to use sine to make it simpler. Because cosecant is really 1 over sine, but I'm just going to leave it as sine for now. To make things a lot easier.
Does that change your answer?
No. I just want you to see, because cosecant and sine are really side, but some of you said, Mr. Let's be more accurate and go 1 over sine. Really makes no difference to me. You can have a 1 over. The only reason I want you to do this is now, guys, gals, I want you to draw this graph out, which you already did up here. There's your graph. This is the reason why I gave you this graph to begin with. Okay. I want you to put a dot where it crosses center line on your graph. So this is my equation. There should be 3 dots. Use a different color if you have to. Here's 1 dot right here. Dot. That's where it crosses center line. Another dot right here. And finally, another dot. Okay. So it says step 3, find your asymptotes. This is where your graph. So I have 3 asymptotes. You can use.
Your pi by 2 disappeared.
Oh, my pi by 2 just somehow keeps disappearing. So I want you to draw in a vertical dash line, because this is asymptote. Remember back in log, asymptote is an imaginary line that your graph can never cross. So these are like boundaries, look but don't touch lines. Just like you guys have your own boundaries, look but don't touch. You have your own asymptotes. Just don't touch someone else's asymptote. So you guys just look but don't touch. Now, here's what it means by go with the flow. I'm going to start on this one to make your life easier. Use a different color pen. It makes your life easier. I'm going to use green. Start up here where it's close to the asymptote. Somewhere up here. Doesn't really matter where. And go really, really close to it, but never touch it. Go all the way down, 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 down.
Where are you?
Oh, well, I'm right here.
Okay.
Okay? So what you're going to do is you're going to start here. From a really close to asymptote, go down, 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 down. And you touch it just once. And you go back up again. Okay? So you start from up here. You go down, 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 and you touch it just once, and you go up. Hey, but there's another point right here. How would this curve look like?
When you go downward.
Okay, now you start from down. And watch what I'm going to do. You go up, 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 up. You touch the very tip just once, and you go back down. That. So the green line really is your graph. So you can erase original now. If you erase original, that is your graph of
Did you erase it?
Yep. So this is your actual graph, just two loops like this.
So that's what it is to do a sine graph.
That's what it is. Your sine graph
Sorry.
tells you what your cosecant one looks like.
Draw it again.
My original sine graph?
No, the new one properly.
The new one?
Oh,
I-
is that how it's supposed to look like?
Yep. That's it.
Just like that?
Just like two curves.
That's so odd.
See? I'm going to give you a question. See, this is just one cycle. Of course, it goes on. You can have another one up here, and so on and so on. That is called cosecant. You can't do cosecant until you master sine and cos. Try this question on your own without my help. Okay. Y equals to 2 secant pi theta minus 4 plus 6. I'm going to give you a minute. I want you to draw the rough sketch for me of what does this look like. I'm going to pause. First thing, I know secant. Just mean is secant, cosecant. Sorry, secant, cos or sine.
Pardon?
Is secant, cos or sine? Whoa, 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 whoa. Cos. So right off the bat, I know this is a cos graph. Now, somebody, if you really like, you can go 1 over cos, but it really makes no difference to me. Because I only want to know what the rough shape of the graph looks like. Again, do it. Now, this is going to be, just draw this. I'm going to start somewhere here. We'll call this 4. And it's going to go all the way, all the way, all the way down. And then all the way, all the way, all the way up. Voila. Okay. And just now we're going to label. Make sure your labeling is correct. This is going to be 6, 8, 4. I'm going to label my ending point. Your ending point should be 6. Because your period is equal to 2. Okay. Now, I'm going to label halfway, which is 5. And really, this is 4.5. This is going to be 5.5. So guys, there's my step 1 and step 2. I want you to go ahead and do step 3 and draw on your asymptotes right now. To draw on your asymptotes, if you look at this, I have 1 dot here. Okay? I have 1 dot here. And look what I'm going to do. Gonna draw this in. Just draw all the way through. Don't be shy. Just all the way through.
So like I know the maximum can be asymptote?
Your min and max, no. Only the center line. I'm gonna start with the one to this right side. Okay? Imagine this graph keeps on going. Because you're gonna imagine this keeps on going. Because this is only one cycle, remember. I'm gonna use red as my reciprocal. So I'm going to start really close to the asymptotes. And I go down all the way, all the way, all the way, all the way. And I touch. Okay. Technically, it should go back up again. But the reason why it doesn't go back up is because I didn't show you anything up here. There should be another asterisk. You go like that. I want you to do the middle piece on your own. There's a middle piece right here. Draw the reciprocal of that line. This goes like that. So take a minute and just do the middle piece on your own. Then after I'm going to teach you how to find domain and range and the equation of the asymptotes. And this is your lesson for today. Okay? I start really close to this asymptote. And I go all the way up. And I touch just once. Just go up. And I just touch it once. And I go back down. Okay. Question? Asymptote on both? This one? Yeah, it could, imagine it keeps on going. Okay? This is one cycle. So there should be another asymptote somewhere here. So imagine there's another one somewhere here. Because we're just imagining. Sorry? You could have one at 3.5. 3.5. Yep. Because each one is 0.5 away. Okay. So again, draw this one. Up here somewhere. And it touch. And just imagine what it looks like if it were to continue on. So we're up here like that. Once you finish this, erase your original coast graph right now. And that's what you have left is your graph.
Wait, do we keep our imaginary asymptote as our answer?
You do. You keep it there.
No, keep over here.
Sorry?
3.5.
3.5? No, you don't have to. But this is just show you what it looks like. It keeps on going. So guys, gals. Sorry? You don't have to erase it, but it just teaches you what it looks like. This is your actual answer, not the original one. These red lines is a graph of 2 secant pi. And voila, question.
If we don't erase it, is it like wrong?
No, it's fine if you leave it. But when you show me an exam, highlight the true real curve, not the original one. The original one just lets you have a chance to look at see what the new one looks like. Now I'm going to ask you part B to this question. Find, because they will ask you this on exam, find range of that equation. You can't do the range until you get your graph. A lot of people try to do this and then they get mixed up in their head. The best way to do it is just draw a graph out, because once you have your graph, you can tell me what your range is right now. Take a look at it and see what your range is.
Y is greater than 8 and
Y is greater than 8 is correct. Because look at here, the lowest point you can have is greater than or equal to 8. So let's write this down.
Do you have another one?
You have another one. I'm going to let you have a minute to figure out what the other one are you on. One is Y is greater than or equal to 8. Because look at this. My graph is higher than 8. The other one is Y is less than or equal to 4. So in this one, I have two ranges. Oop, it's loading up something. I think I touched something. It's called the grumpy virus. My other one is Y is less than or equal to 4. Oh, come on, get my 4 in. There we go. Because
If you write one big line, how do I put this on?
no, you can't write one as one line. It has to be broken up. Okay.
No, like if you write, oh yeah.
You can't write as one line. You do not do this. Please do not write it like this. Do not write. Because somebody say, Mr. Let's be lazy and write as 4y8. This is saying y is between 4 and 8, but there's nothing between 4 and 8. Okay? So you have to write it separately when it comes to cosecants. So guys, gals, be careful about this. Do not write as if you're mixing together everything as one. That's called your range. The next, domain. And this is where it gets a bit tricky. If I look at this one, you're going to write your domain as my graph goes everywhere. There's only a few key spots my graph can never hit. Find those key spots right now. Your asymptotes. See, I can have every x value there is except for these asymptotes, because the graph would never touch these asymptotes. So let's write a few things down. Domain. All values except, because that's what the purpose of asymptotes is. It's a boundary. It says look but don't touch. All values except asymptotes. No. This is how the English would write it. But we're not English. We're mathematicians. Oop, asymptotes. To write it mathematically, this is how you would write it. You can write down all reals. They use a capital R. And you're going to say x cannot equal to. Okay? That R means all reals, means there's all values. And then you're going to say x cannot equal to 4.5, 5.5, dot, dot, dot. 4.5, comma, 5.5. I'm pretty sure you can give me the next one now. 6.5. But really, I can sit here and write every single number, and I still never get to the end. So there has to be a generic formula for this. And I'll give you a hint. It has something to do with your period. This is called the asymptote formula. They're going to ask you, what is your asymptote going to be? To do the asymptote, here's your formula. First asymptote, plus n period over 2. N period. And you're going to write one more thing. N E I. It sounds confusing, but I'll explain to you everything how this works. Okay. Hi, question. Oh yeah, good point. You could do plus or minus. Thank you. So some of you say, "Must know what the heck is this? I don't understand how this works." If I look at this question right now, your first asymptote you know is 4.5 for sure. The next asymptote over is one distance away, right here. Would you agree that's half a period? So that's why every half a period you get an asymptote. That's why it goes your first asymptote plus half a period. I use n because I don't know how many asymptotes there are. And I go NEI means your n has to be a solid number, can't be a decimal number. So guys, gals, let's rewrite this properly. So they're going to ask you your asymptote is 4.5. Alright, so you're going to write down x equals 2. This is the difference between domain and range. Asymptote is a formula x equals to 4.5 plus.
Don't you mean domain and asymptote, not domain and range?
Oh, sorry, domain and asymptote. N. My period is 2. So we're going to write down 2 divided by 2. 2 over 2, comma, NEI. But I can simplify 2 over 2 as 1. So your answer really is x equals to 4.5 plus n, comma, NEI. Oh, and just says that n cannot be a decimal number because your n has to be a solid whole number. Question? No, it doesn't have to be. But in general, what the book does is they use the first asymptote to make your life easier. Okay. If you want to use 5.5, it also works. Okay. But on your answer key, they will use the first asymptote. That's what you got to know. Try this on your own. I'm going to walk around. I'm going to help you out a bit. That's your answer right here. So they're going to ask you 3 things. What is your range? What is your domain? And what is the equation of your asymptotes? On exams, 3 things will be asked. Those are the top 3 things. Everything is derived from drawing your graph. We're going to give you another question. After this, I'll give you the supernode question. We're going to see how you guys do. Actually, should I give you supernode now?
Yeah.
Okay, I'm going to give you supernode now. Let's see how you do. Oh, grumpy. This is your supernode question today. Good luck. Y equals to 4. Should I do cosecant or secant? Secant. Secant. 4 theta plus pi minus 2. I'm going to ask for a few key things. Number 1, what is your range going to be? Now, I would give this on my last year's exam. A simple question. I asked you for a range and domain. And a lot of students sat there don't know what to do. Anytime you're given a secant question or cosecant question, graph it out first. Get a picture of it. Once you have a picture of it, you can get the range and the domain easily. What is your range? And what is your domain? Finally, what is your asymptote going to be? Look at my formula for asymptote. It's your first asymptote plus half a period, because that's when it repeats itself. Guys, gals, three things. Get crack-a-lackin'. I'm going to pause it, give you both. Hi. Yeah, thank you. I'm just going to quickly draw a rough sketch for you and just quickly label the x-axis. And if you're having trouble how I label my x-axis, please come after school today and I'll work with you. I have a point right here, and my graph should look like that. Negative pi. Negative pi by 2. Okay. Now, really, what I'm looking for are these key points. This is the reason why I've been harassing you. You got to make sure you label your x-axis correct. And some of you say, but Mr. No, I don't see a point in labeling these. Now you see the point. This point really is negative 7 pi by 8. If you're having trouble with getting these points, review the earlier lessons. This is negative 5 pi by 8.
Your center is...
Now, this here is negative 2. This is 2. This is negative 6. I'm going to draw in my asymptote. Okay? And again, every time you're given one of these questions and asked for domain and range, draw it out, please. A lot of people don't know what to do because they don't want to draw it out. On your homework, just draw a rough sketch. I'm not asking you for a perfection graph. I just want to see a rough sketch. So now, here's what my graph looks like. Down, down, to Chinatown. And voila. The reason why you draw this out is it shows you right away what your domain and range is. Without having this graph visually in front of you, Robert. I have to calculate it, but I have to see.
Wait, what?
Okay, I will calculate it. If it's right, I'll give it to you. Okay. So this is your range. Y, make sure you do this, please, is greater than 2. Y is less than or equal to negative 6. I need these two. 1 alone is not correct. 2 is correct.
I went like this.
My domain. So this is my range right here. Range. My domain, you should always write. Some people like to do R reals. I'm going to do this fancy R. In university, they use this fancy R. And they're going to say x cannot equal to your asymptote. Well, I know my asymptote is negative 7 pi by 8. I know my asymptote is also negative 5 pi by 8. But really, there's a formula for this. And here comes my formula, which is your asymptote. Finally, your asymptote formula. Wrong. That's 2 s.
Wait, so the is there any range domain near the asymptote?
Too much s's in one day.
No.
Sorry, we were laughing my own. Sorry, go ahead. Grumpy, I'm laughing at my own jokes. I'm just so busy at my own jokes, I didn't hear your question.
Are you recording this?
Yeah, it is recording. So, guys, gals, again, you choose your first asymptote. Some people like to use negative 7 pi by 8. Some like to use negative 5 pi by 8. Really, it doesn't really matter. Negative 7 pi by 8 plus. Now, it repeats at every half period. So, which is n half period. And my period is pi by 2. So, your true answer is negative 7 pi by 8 plus or minus, if you want, n pi by 4. And I always write down NEI. On provincial exams, they actually deduct a mark if you don't use NEI. Because NEI means that n has to be a whole number. Okay? N has to be 1, 2, 3. You cannot go 1.1 for n. It has to be a nice solid number. Guys, gals, that is the end of your lesson for today. Plus, minus. Which means I can go either way for asymptotes. And your work. Page. That's all there is to it for today. Da, 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 da. Page, what page is this? Can I give it to you? And all it is practice on domain and range.
That's all?
That's it.
How about graphing?
There's no graphing.
But then you're gonna give us a quiz on graphing.
Tomorrow I will. Yep. And to do domain and range, you have to do graphing.
But, so you
Page 72.
Ignored.
still gonna quiz us on the graphing.
I want you to do
Draw the graphing.
focus.
Oh my gosh, that's stupid.
Focus only
Not you.
on.
Who's got more? Okay, you really have more.
Secant and cosecant.
Whatever, man.
Yep. Ignore tan / cotangent. I didn't teach you that yet, so you can't do it. I only want you to do secant and cosecant. It asks you for equation asymptote. It asks you for the period and asks you for domain and range. That's it. Draw a rough sketch. The key, graphing helps with this thing. A lot of people try to do this in the head, but draw a nice sketch. It helps you out.
Cards from yesterday.
Oh, and give me 1 second.